Bismillahirrahmanirrahim. Assalamu alaikum. We are given with this system now. Consider this system where a is minus 1, 0, 1, minus 2. So you can see that our system is going to be x prime to be minus x and y prime to be x minus 2y. And you know that this a is not in the canonical form. Now what we will do, we will transform this system into another system where this matrix form will be actually the canonical form. So all we need to do is we need to calculate the eigenvalues. Okay, eigenvalues of a. So for this we need to calculate the determinant of a minus lambda I to be 0, which gives me determinant of minus 1 minus lambda 0 1 minus 2 minus lambda to be 0, and it is not hard to show that this is lambda plus 1 times lambda plus 2 0, and which suggests that lambda is either minus 1 or lambda is minus 2. Now I want to calculate the eigenvector corresponding to lambda equal to minus 1, and for this I need to solve this system a minus lambda I operating onto some unknown vector x and to be 0 column vector. So this is going to be minus 1, and then this is going to be plus 1 0, this is going to be 1, this is going to be minus 2 plus 1, all of this operating onto xy, and this is 0 0. Okay, so we get 0 0 1 and then minus 1 times xy to be 0 0. This gives me y to be x, which means that if x is t, then y is also t. That means the v1, which is eigenvector, is going to be 1 1. This is going to be my eigenvector for lambda 1 equal to minus 1. Now I will calculate the eigenvector for lambda 2 equal to minus 2, lambda 2 equal to minus 2. For this I will solve a minus lambda 2I operating onto x, all of this equal to 0 column vector. This gives me minus 1 plus 2 0, then 1, and then minus 2, this is going to be plus 2, and all of this operating onto xy set to be 0 0, which gives me 1 1 0 0, and this is xy, which is 0 0. This gives me x equal to 0 and y can be anything. So that means that v2 should be 0 1. Okay, so let's conclude the discussion. So for my matrix A with entries minus 1 0 1 minus 2, my lambda 1 is minus 2 and corresponding vector v1 is 1 1. My lambda 2 is minus 2 and my corresponding eigenvector is 0 1. You know that both the eigenvalues are negative, so the behavior has to be, sync. How will it behave on the phase portrait? We have already discussed it in detail in the previous videos. You can go and watch them. But now we just want to convert this system x prime to be ax dynamical system into the system where this matrix form is canonical. So now I'll define t. What is going to be t is nothing but having these column vectors 1 1 0 1. This is my t. Now I need to calculate its inverse, and it's not hard to show that its inverse is 1 over determinant of t. So the determinant of t is going to be 1 over 1, and then adjoint of a. So the adjoint of a is going to be 1 0 minus 1 1. Hence the t inverse is 1 minus 1 0 1. Now I want to calculate t inverse a t. Okay, what is this? So my t is here, my t inverse is here, so a is here. I just want to compute these quantities. So t inverse a t. My t inverse was 1 0 minus 1 1, my a was minus 1 1 0 minus 2, and my t was 1 1 0 1. Okay, so now 1 0 minus 1 1, let's compute this. So this is going to be minus 1, this is going to be 0, this is going to be minus 1, this is going to be minus 2. Now we multiply these, so this is minus 1, and then this is going to be 0, this is going to be 0, and then this is going to be minus 2. So you can realize that now this t inverse at is the canonical form, and I can now define a new dynamical system in the variable y, that is t inverse at y. Okay, so now this matrix is minus 1 0 0 minus 2 times operating onto, maybe you can say y1 y2, and you can write y1 prime and y2 prime, maybe other variables. Okay, so now solution to this system is not difficult. Okay, this kind of system has already been discussed, where we had considered this lambda 1 and lambda 2 with certain condition lambda 1 and lambda 2 less than 0. For this system you can easily solve this solution to be equal to y of t equal to some constant alpha e to the eigenvalue 1, which is lambda 1 t times 1 0, plus beta times e to the second eigenvalue times t 0 1. Now I need solution to this system x prime equal to ax. This is the solution to this system, but not this parent system that we had in the start. So all you need to do is to multiply ty of t, and this will be x of t, which will be solution to this. So you just will multiply t alpha e to the minus t, t will be operating on to 1 0, plus beta e to the minus 2 t, and then t will be operating on to 0 1. And then you can easily show that this is e to the minus t with 1 1 plus beta e to the minus t, this is 0 1. So from this discussion the conclusion is, if we are given with the system x prime equal to ax, then we can define t where a has two distinct eigenvalues. Okay, so we can define a t in the form eigenvectors v1 v2, and then we can define t inverse some matrix, then t inverse a t y equal to y prime equal to t inverse a t times y. This will be a new system that will be transforming this system into a new system, and now we can easily study this system and solve this system. Once we have solved this system, then we will multiply ty and we will get back the solution of this system. So here you can easily realize what is going on. For example, in the previous example we had x prime equal to minus 1 0 1 minus 2 times x, and when we converted, the system became y prime equal to minus 1 0 0 minus 2 y, and we know that this is having eigenvalues, both the eigenvalues are negative, so this system is showing uh, showing the equilibrium point 0 0 sink. And what is going on like on the uh, graphs, let's show on phase portrait what is going on. So that's here, this is the graph for t inverse a t y with y prime, and this is the graph for x prime to be ax, where a was given by minus 1 0 1 minus 2. So you can see that in both the cases the trajectories are moving towards zero origin, so like both are sync, just the difference is of the direction. So like this is the originally x prime equal to ax version, and this is the transformed version y prime equal to T inverse A T y. Okay, so this is the solution for T inverse A T y, or the one in the canonical form. So this is the canonical form version. And what T is doing, so y is the solution, then when you applying this T, it's going towards the original, and which is this one. This one has already been discussed in the previous parts. If you have any confusion, you can write down in the comments, or you can discuss with me later on. Thank you.